Hello! We did it. Before I forget, strangely, Rick and Morty released a new episode on YouTube, like freely available, the new episode of the new season. So, yeah, I haven't watched it yet. As soon as this is over, I'm going to go watch it. But if you're a Rick and Morty fan, there's like a brand new episode just popped out about 12 hours ago. So go do that. It's awesome. Miguel Angel Romero. So how long until the long-awaited, for Fraser, but dreaded for us, hiatus? End of the month. So one more. Yeah. So I'll do an episode. I'll do an open space or next week, and then I will go on hiatus for 2 months. So, yeah. I feel bad. I do feel bad. And at the same time, I know it's good. It's good for me. It's good for you. And you won't even notice. And then 2 months will be over and we'll be back in September. Although I could very well be recording from a trailer. So, yeah, or outside. So it's going to get weird when I do come back, because this will be gone. This will be sold. This will no longer be in my possession. This is already owned by somebody else. Well, not exactly, but so we'll be moving to our new property, and it's literally just trees and dirt right now. So, and our trailer. So it's good that I do this hiatus, because I will have really bad, no water, no septic, no electricity, no internet for at least a month plus. But anyway, so that's what's going on in my life. But this is the penultimate episode. I hope you guys got a chance to watch the interview today. It was absolutely fascinating. Lee Cronin is a chemist, but has come up with some really clever ways of searching for life, both as we know it and as we don't. It's sort of like nice generic tests for the search for life. And I think you'll find the conversation absolutely fascinating. It was unexpectedly insightful, and it's sort of some ideas that I'd never even heard before, and I thought it was great. So if you haven't had a chance, definitely watch the interview, and I'll try to get a couple more interviews queued up before hiatus time. All right. Okay. All right. So go ahead, post any questions. I don't have any pre-prepared questions this time, so it's just going to be live stuff today. So dig deep. If I haven't been answering your questions in previous weeks, now's your chance. All right, let's get into it. Let me press the record button. Oh, I don't have a memory card in there. All right. Go camera. Sorry. All right, let's try that. Sometimes my focus mucks up when I do that. All right. Put on the audio. There's Chad. Yeah. Okay. Am I as drunk as you are? No. I haven't had any alcohol in 6 months. I haven't had anything to drink. The last time, at Christmas, my wife bought me a bunch of scotch, and I drank that up. And then I haven't had anything else. It's funny. Like, normally for me, beer is a very social event. So I'll go to meet my friends at the bar or at the brewery, and we'll have some beer. And because of COVID, I don't go out to the bars with my friends, and so I just don't drink alcohol. So, although I'm sure I'll get another bottle of scotch on my birthday. Okay, let's do this. Hey everyone, welcome to the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops in your brain, just write it down, gather it up, and I will answer them here. Once again, I am recording this show in your past, which is my future. I don't know what will happen. The date is June 21st, 2021, but all kinds of amazing things might happen over the next week while this episode is being edited. Who can say? Just to let you know, this is also the penultimate episode before I go on my annual summer hiatus from July and August. So there'll be like one more question show after this, and then I will be mostly offline for the next 2 months, although I'll still be doing the newsletter and running Universe Today, but I won't be doing any live stream either through Astronomy Cast or the weekly Space Hangout. So just to prepare you emotionally for the fact that I'll be gone for about 2 months. All right, let's get into the questions. Okay. All right. Yes, I am recording, Chad. Okay. Estevan Candel. Hey, Fraser, in the hypothetical scenario that our galaxy is bursting with Dyson spheres, what current or future telescope would be able to find out about it? Would we know about it already? So a Dyson sphere, of course, or a Dyson swarm, is this theoretical, futuristic, advanced alien civilization that has fully enclosed their star in some kind of radiation gathering system, whether it's like one big shell, probably not a big shell because that wouldn't be stable and it would drift around and it would be bad, but probably just like a swarm of solar satellites that are buzzing around the star. They're collecting every single photon that gets out of the sun. They're using it for who knows what, computronium. They're running a giant universe simulation. I don't know. This is where I make my Crisis 3 joke. But who knows what they use all that much power for. But they're doing it. And we can calculate that it will take us, I think, about 2,300 years from now until the point that, if our energy use continues on the upward curve that it does, we will reach the point where the amount of energy that we'll be using is the amount that is emitted by the sun. And so then how do you get all of the radiation that's emitted by the sun? You enclose it in some kind of swarm. So that's a Dyson swarm. Is it guaranteed? No, absolutely not. Of course. There's going to be a certain group of people who are like rolling their eyes at the idea of a Dyson sphere. Like, who's to say that we will continue our never-ending, increasing demand for energy when we can figure out some kind of balance with whatever, right? Who knows? Since the history of mankind, have followed an exponential scale of energy usage from the beginning, like for the last million years. Definitely through the agricultural revolution, definitely through the industrial revolution, our use of energy continues to go up. And so you just take that line and you just continue it on into the future. Make little dotted lines where the energy use will go. It'll increase and increase and increase, and boom, you're using all the energy of a star. And then if you just keep that line going up, it doesn't take long. Really, the part that takes the longest is the amount of time that it would take you to actually travel from star to star and put these Dyson spheres around every single star in 100 to 400 billion stars in the entire Milky Way. And that would only take you, again, probably about 1 million years after that. And the time is the travel time, not the construction time. So yeah, in 1 million years or so, we will have gone from where we are today to we will have put a Dyson swarm around every single star in the entire Milky Way. Or not. Who knows? But it's something to think about. I'm not saying you should. I'm just saying, let's just think about it. So then if you did that, you would have this swarm enclosing the star. All of the photons of visible light, X-ray radiation, heat are all coming out of the star. They're hitting this Dyson swarm. They're being converted into electricity for some purpose. And then because of the laws of thermodynamics, these things have to give off waste heat. And so they will emit this waste heat in all directions, but effectively from our perspective, we will see the waste heat signature of a star. And it will have a similar signature to the star itself, because you're essentially getting, in the end, you have to get rid of all of that heat. And so you're just really shifting from the visible light, X-rays, ultraviolet, into infrared, and then you're emitting that out into the universe. And we have very powerful, very sophisticated infrared telescopes, and they would absolutely be able to detect a Dyson swarm in our vicinity. Or if the aliens had enclosed every star in their entire galaxy, they would be able to detect the infrared signature of an entire galaxy. It would look utterly different than a galaxy as we imagine today. When you think about some of the most beautiful pictures taken by the Hubble Space Telescope, and you're looking at this incredible galaxy with its spiral arms and dust clouds and centers of star formation and globular clusters in the central core. Imagine that whole thing, but now it's just blobs of heat. Every single part of it is heat. You would detect portions of it being turned into Dyson swarms. You would detect the entire galaxy would give off this very specific signature of Dyson swarms. It would look utterly different. And astronomers have gone and looked for this. They've done surveys both to look for Dyson swarms here in the Milky Way, and they've done surveys to look for Dyson swarms in, or type 3 civilizations, galaxy-wide Dyson swarms. And so far, none have turned up. So if any alien civilization is in the process of colonizing their entire galaxy, we haven't seen it, or creating some expanding sphere of colonized space through all of the galaxies that they can reach within their observable horizon, we haven't seen that either. We would see that. We would see these galaxies have all turned to the infrared. We could almost measure the size of their empire, and we don't see it. So far, no one has seen it. And so currently, from our perspective, all of the universe that we can see has been unclaimed by Dyson swarm building alien civilizations. So that's sort of our current state. And of course, the thing I always like to say is that people always say like, oh, we'll never build a Dyson swarm, but we have already begun. When you think about all of the telescopes, the space telescopes that have been built so far by NASA and ESA and et cetera, that are orbiting the sun, that are harvesting the energy from the sun to power themselves, like SOHO and things like that, that is the beginning of our Dyson sphere. We've already begun the construction of our Dyson sphere. The moment we launched our first solar-based telescope into space, the construction of our Dyson sphere began. And eventually, some future alien civilization will be able to detect it. Whoa. Mandara, what do you think about SpaceX splashing down a Starship next to Hawaii for the upcoming orbital test? I haven't heard that. Is that the plan? I haven't heard him say that. So, so Minty Smith, you're asking why gravity has the same speed as light. I answered this question fairly recently, so I don't have the link in my mind, but it's within the last probably 5 QAs. The answer is essentially that why are they the same speed as light? That's just the laws of physics. Why is anything anything? Why is there something and not nothing? Why is the force of gravity what it is? Why is the speed of light what it is? But we do know that they're the same speed, and that's because of the kilonova event. We were able to see the gravitational waves from that event arrive at exactly the same time as the radiation that was emitted by these two colliding neutron stars. And that told us that gravity and light move at the same speed. Vondre Bernazzo asking about the pros and cons of a telescope on the far side of the moon versus a space telescope. So I've done a bunch of episodes about telescopes on the far side of the moon, and talked about those ideas. So maybe search my channel a bit. Just like within the last probably couple of months, I interviewed someone who's like one of the project directors for one of these telescopes. So but there's no real value to putting a telescope on the far side of the moon, except for a radio telescope, because it's blocked by the moon to block the Earth's electromagnetic radiation. So it just gives you a better platform. Adam Camierns, how big a laser would need to print circuit on an exoplanet surface? I have no idea. Big to reach an exoplanet? A laser the size of the Milky Way? Okay. Let's do this. Jay Brodeer, could a Falcon 9 or Heavy reach Hubble, and would it be worthwhile to do a servicing mission? So the last time that the Hubble Space Telescope was serviced was with the Space Shuttle. And it did a couple of servicing operations, was able, that initial repair that fixed the problems with the Space Shuttle's optics, and then follow-on missions to replace some of its gyros as they were breaking down, as well as upgrade the electronics. And it's sort of ended up being a very useful way to run a space telescope, that you can launch the telescope and then you can upgrade it. At the same time, the Hubble Space Telescope has been very expensive. It was expensive to build. It was very expensive to fly the space shuttle and to do all of those repairs to the Hubble Space Telescope. At the same time, though, of course, James Webb, which won't be repairable, is going to be insanely expensive. So who knows what's the best way to go about this? Could theoretically a group of astronauts get in board a Crew Dragon 2 on top of a Falcon 9, fly to the Hubble Space Telescope? Yes. The orbit of the Hubble Space Telescope, it's different from the International Space Station, but it's roughly similar. And so it was designed to be reachable by the Space Shuttle, and it's reachable by a Falcon 9 with a Crew Dragon. But the Crew Dragon doesn't have the same kind of capabilities that the Space Shuttle did. It doesn't have a wonderful Canadian-built robotic arm. It doesn't have the kinds of facilities to allow the astronauts to do spacewalks. It's not really set up for long-term habitation on board the spacecraft. Although the Crew Dragon is pretty big. Like, the Crew Dragon is actually about double the volume of the Apollo module. So if you just sent up a couple of astronauts, they would have lots of room to hang out inside. But I can imagine a variant of the Crew Dragon that's designed for orbital resurfacing. And you could imagine, if things get to that point, that a Crew Dragon could launch and send a couple of astronauts, and it's got some sort of cargo bay doors, and it's got a robotic arm that can hold on, and they could do a bunch of repairs to the Hubble Space Telescope. And who knows, maybe at some point that'll be a decision that someone decides to make. The other possibility, of course, is that the Starship could just kind of gulp up the Hubble Space Telescope, bring it back down to Earth inexpensively. They could fix it down on Earth, put it back in Starship, it could fly back up, release it again. So there's a lot of really interesting ideas that'll happen when you've got a reusable rocket capable of grabbing things from space and landing back down on Earth. Again, I don't think we've really explored it. So right now, there are no plans to repair Hubble again. The only plans are to deorbit it when it stops functioning properly. But it's cool to think about. And who knows, at some point, someone will make the cost-benefit analysis on whether or not it makes sense to do it. Open the pod bay doors, Hal. Devon, I want to point out that I'm amazed at how you're able to nail your intros, outros in a single take. Can't work with journalists on a daily basis, and most can't. Well, I've done hundreds. I've probably done thousands of this kind of thing. So after a while, you hope that practice gets you good at this kind of thing. Also, I think it's okay to have sort of human expressions, to use various ums and ahs in the conversation. If you're trying to reach some destination, people are fine with it. I mean, you think about the way people consume content right now. Like, they watch Twitch, they're like playing some video game, and there's someone playing the exact same video game on another window, and they're just mumbling and blah blah blah, and the game is going on. Like, that's the nature of modern media right now. So if you can just get like any better than someone playing a video game on Twitch, then I think you're doing all right. Um, nuking Mars, the focus is a signal of our arrival. That's a terrible idea. Scrambles, you're asking about the interview today. If the instrument would fit on a rover, I think he said it would that a future version would be able to be held on a rover. So I think the answer to that was yes. Okay, all right. We'll do this one here. Oh, oops, sorry. Okay. All right, we've answered this one before, but maybe it's been a little while. So, Francisco Sins. Can we harvest 100% of the energy the star produces without leaking or losing in radio or infrared? We get this question a lot, and I guess it's just a follow-on question to the whole how can we detect Dyson spheres, which is then like how can we hide a Dyson sphere? If we've got all of this capability of energy, if we're storing all of the energy of an entire star, can't we figure out a way to not leak that energy out into space so that aliens can know that where we are? And it's like the one answer is no. No, the laws of thermodynamics say that you have to release heat. And sort of think about it from a logical point, like if you are gathering all the light coming from the star and you're enclosing it in a sphere and you are using that energy for whatever kinds of purpose and none of that energy is getting out, then you are building an oven. You're just going to have the temperature inside your sphere rise and rise and rise and rise, and eventually it's going to be thousands of degrees and tens of thousands of degrees and millions of degrees and billions of degrees as the sun keeps on putting out heat and you keep on capturing it and not letting it escape out into the universe. And so you have to release that heat somehow. And often release of heat on a spacecraft is as big or more of a concern than getting energy in the first place. Spacecraft engineers have to think about the release of heat through radiators just as much as they have to consider how much solar panels they're going to put on the spacecraft. You can see on the International Space Station, the radiators are a huge part of the station. You think there are other solar panels, but they're radiators. So no, you can't, as we understand the laws of physics today. Now, I can imagine you could figure out some way that you might be able to lengthen the waves to push them into the radio so that someone would need a very specific kind of radio telescope to be able to do it. But at the end of the day, you do have to get rid of that heat. I can imagine some other possibility. Like maybe you've got a pet black hole that's also orbiting around inside the star, and then you're gathering up the heat, and then you're firing it as a laser into the black hole, and it's absorbing the energy, the leftover energy. But still, I mean, even the laser is going to be releasing heat. Like you're going to have gadgets to collect the heat from things that are collecting the heat. And at the end of the day, we follow the laws of thermodynamics in this universe. So there's just no way to do it. But if the laws of physics don't work as we understand them, who's to say what will happen in the future? Phil DeShane, I still haven't read Andy Weir's book. I'll put it on my list. I promise. I got 2 months. I'll get through all kinds of books. Oh, that's a good question. I like this one. All right. Celestial Navigator. Do you think computers will completely replace humans in the field of astronomy? No, I don't think computers are going to replace human beings. I think humans have a very important role in the process of astronomy. But at the same time, computers do an enormous amount already. Like astronomers are bordering on computer scientists. Like, I don't think they want to admit it, but when you ask them how well they're able to program in various programming languages, they're masters of Python. They're able to comb through databases. They communicate with their telescopes robotically, programmatically. Like they do a ton of computer work to be able to do their jobs. And if you think that you're going to be able to become an astronomer without learning to also become a computer programmer, you're just fooling yourself. So, but I really like this idea of the centaur, and the idea is that you've got a human being working with a computer together as a partnership. And there's things that human beings are very good at, and there's things that computers are very good at and very fast at. And so the trick is, over time, you're able to push more and more of the manual grunt work into the hands of the computer, as opposed to having sort of a human being do it. But that frees your mind to think of new ideas, to explore new spaces. And so when you think about in the olden days, you might have astronomy professor with a whole bunch of grad students, and then the professor will be working on some paper. They'll give all of the grunt work to the graduate students, and they'll have to sit for weeks doing calculations, and now you can just have a computer do it. And so now the professor can think of more ideas, the grad students can progress on the papers, they can use the computer programs, and the whole science accelerates. And so that's really what computers do. But I'm a huge, if anyone thinks that they can automate things, I am very skeptical. And that's my background. Like, my background is building tools to automate things, and I'm very skeptical. But when you have this balance where the people are doing the jobs that people are really good for, but the computer programs that you're running are working with you to enforce the rules, to be able to take off a lot of the work, to be able to act as a very good checklist reminder, it's a perfect partnership. And I think it will always be the case. And anyone who tries to over-automate things, it's kind of doomed to failure. And anyone who under-automates things is sort of left behind. And the trick is to find that balance all the time based on the level of technology. But I mean, artificial intelligence technology these days is quite amazing, that you can start to provide image classification, crater counting, find really small signals in enormous amounts of data. And it's just going to continue on into the future. But humans will still be running the show. Until, obviously, the robot uprising and we all merge with our computers and after the singularity. But, until then. Apologies, just looking at all the questions. Visto 2D. If Venus has a biological system, will the planned probes have the ability to detect life? The current missions that are heading to Venus, there's the Da Vinci Plus mission and the Veritas mission, and neither of those are really going to have the ability to search for life on Venus. I forget which one is which. Veritas is going to be an orbiter. It's going to be scanning the surface, doing a much more detailed observation. The Da Vinci Plus is going to plunge through the atmosphere and take snapshots of the atmosphere all the way down. And of course, the European Space Agency has announced their own Venus mission as well, that's also going to participate in doing a very detailed scan of the atmosphere and the surface of Venus. So, but no, none of those are going to be capable of continuing on this search for life on Venus. We're going to need a pretty special follow-on mission to do that. I haven't heard of any that are in the works. I know that some people have proposed some ideas, but I haven't heard of anyone very seriously taking on the idea that, we're going to send a mission to Venus to search for phosphane and other elements. But I think the search for life is going to be really, really complicated. Just as it's been complicated at Mars, it's going to be even more complicated at Venus, because just how harsh the conditions are on Venus. I mean, here we are, right? The Viking probes landed on Mars back in the 70s. So we're like 40 years after Vikings landed on Mars with instruments on board attempting to detect life, and we still don't have a definitive answer of whether or not there's life on Mars. So then when you think about the Venus, like it's that it's that complicated, but also in hell. And so you're to try to float around in the cloud tops, have a balloon mission, be able to sample the various chemicals, to be able to do any kind of analysis, be able to send that data home. No, nothing that's in the works right now is going to be able to do that. But I have done an episode, I'm sure you've seen it, on various aerial missions that could go to Venus. And there's even an idea for a human mission to Venus that would float in the cloud tops and try to do some of this kind of science. So maybe in the next few decades, someone will be able to do this. Whoa. Steve Coates, could you make a repeating gravity wave generator? Well, sure. There, I just made a repeating gravitational wave generator. Whenever you move mass in space, you are generating gravitational waves. So if you wanted to make something that was detectable over long periods of time, you just need to have something that was moving more rapidly, that contained more mass, like a couple of neutron stars or black holes orbiting around each other. But the problem is that when they get to the point that they're really starting to generate gravitational waves that are detectable over long distances, they are spiraling inward and they're about to merge. So can we somehow move a mass like a black hole without it merging with another black hole in some way? It just seems like very, very difficult. But who knows? It might be that as we get better and better at detecting gravitational waves in the future, we'll get to the point where instead of just detecting, say, the black holes 1 minute before they collide with each other, we'll be able to detect them decades, centuries before they collide with each other. Maybe they're just going to be a little farther, wobbling around each other. And so maybe some alien civilization could figure out a way to make those black holes wobble in such a way to be able to release gravitational waves. But then, of course, you could just shine a laser beam at someone to communicate if that's what you were trying to do. So, yeah. Jeff Sonderman. Hey, Fraser, what current piece of today's conventional wisdom about space and astronomy do you think is most likely to be disproven by science later on? That's a difficult question for me, I think. Let me do this again because I wasn't looking at the camera. That's a difficult question for me to really answer. Because I'm really in the weeds on this. And so when I think about something like, say, dark matter, I don't think about dark matter as just here's this weird mystery that astronomers don't know about. I think about it like all of the different pieces of evidence that have been gathered so far to explain dark matter, all of the ways that they use observations, all of the different theories that have been proposed to be able to try to explain it, all of the different experiments that can be done down here on Earth to search for particles, various astronomical searches for it. It's this very complicated, nebulous thing. And every astronomical thing that I think about when I think about fast radio bursts, so I think about dark energy, or I think about any of these things, they all exist in this very complicated sort of multi-dimensional reality. And when things advance, they tend to advance very slowly. So you sort of don't notice this change. Pamela and I with Astronomy Cast, we went back and, every decade or so, we do a series of episodes where we look back and sort of think about what's changed since we started doing Astronomy Cast. And there aren't a lot of big things like like there aren't big, big dramatic changes that have happened, even in the 15 years that we've been doing this show. But there's a lot of little ones that build up to ones that kind of in retrospect sort of seem really big. But people just want to ask us, like, what's the big change that's happened that's overturned? And I can't think of any. Like, I think dark energy was the last big discovery that caused a deep issue. And maybe the cosmological crisis, this mismatch of measurements between the acceleration of the universe or the expansion of the universe between the Big Bang and more recent measurements. So it's a tough thing for me. Like, I don't want to weasel out of the question, but I just find, like, in general, the more that I learn, the more that I know, the more people I talk to, everything just becomes shades of gray and nuance. And it's really hard to then go, this is conventional wisdom and it's totally wrong. So yeah, I don't, and I also sort of feel pretty humble. Like I'm just a journalist. I'm not an astronomer. And so I don't sit there and do research and come up with theories that, or even work in those kinds of circles. I'm following behind, attempting to recommunicate the things that people are discovering and learning bit by bit. And so I try not to hold an opinion so much about this kind of stuff. So there you go. I guess the one that I've stated many times is that I don't think we'll find life in the universe, which I think if you ask most scientists, they think we'll eventually find life in the universe. And I don't think we will. So I guess that's the most controversial belief that I hold. 37. Okay. Eric 1. Given the current age of the sun and the fact that it will eventually swell up to a red giant, how much longer should the Earth be habitable? Yeah, so the sun is heating up. And it's not just because the sun has hit that red giant phase, but actually the sun is heating up day by day, week by week, year by year. And what's happening is inside the sun, it's converting hydrogen into helium. And this helium is forming this layer on the outside of the core of the sun that is causing the amount of, essentially the size of the sun to increase a little bit, causing the amount of energy that the sun is releasing to go up. And this is sort of increasing the total energy output of the sun a little bit. That's increasing slowly. And this has been going on really for the lifetime of the sun so far, and it's going to continue on. And the bad news is that this increased heating from the sun is going to cook the Earth more like about 500 million to about 1 billion years. So even though the sun itself is going to take, well, I think like 5 more billion years until it runs out of fuel in the core and turns into a red giant, it will have actually already blasted life off of Earth within about 500 million to 1 billion years from now. So within about 1 billion years, the oceans will have boiled and there will be no hospitable place on the surface of the Earth for life anymore. Now, this has nothing to do with global warming. It's way slower than that. So this is but sort of a long-term existential issue that I guess, we or the octopuses that take over will have to figure this out. But it's kind of interesting when you think about it. Earth has been habitable by large life forms, by animals and stuff, for about 500 million to 1 billion years. So we're at like the halfway point of the Earth's productive large animal period, and that will phase out again, and the Earth will essentially just be teeming with microbes underneath the surface until the sun does finally turn into a red giant and blast the planet. You want to double check my answers on that very carefully, Chad. We should talk about that afterwards. I might not have described the helium burning perfectly. So, whoa, graviton laser. I don't even know what that is. That was from Prince Charming. Um, Brandon Loizides, why aren't there any green stars? That question's been answered quite a bit. So I would do a search on YouTube and stuff. I always forget sort of the common answer. It's like the sun. If you looked at the vast majority of the photons coming from the sun, they're actually green. So the most common kind of photon that's coming our way are green. But when you average out the black body curve of the sun, you get the white color that the sun actually is. So no, I haven't read Project Hail Mary. I will read it. I promise. I mentioned last week, I think, I reached out to Andy Weir and asked if I could interview him, and he and his wife had a new kid, and he was like, I'm not doing anything. So much respect. I'll talk to him when he comes up for air again. Hal McKinney. With discovering life outside of Earth seeming to be the biggest driver of space exploration, what's the second biggest motivation? I think I want to argue with the premise of your question in the first place. I don't think that discovering life outside of Earth is really the biggest driver of space exploration. I'd say the biggest driver is being able to make life better on Earth. That's like the biggest driver of space exploration. When you think about all of the rockets, all of the work that's being done, it's to send up GPS satellites, communication satellites, military satellites. Like we learn to go to space so that we can use the benefits of space down here on Earth. And that, I think, is like the first motivation to getting good at space exploration. And then I would say beyond that, I wouldn't say it's to search for life. It's to understand the solar system, both at a planetary, at a high energy physics, at a just sort of like all the various levels, with life actually being pretty far down the list. I mean, there's really only one robot in the entire solar system right now whose job is even barely has anything to do with life, and that is the Perseverance. Like, it has some capability to try to search for the conditions of life in the ancient past and currently on Mars. And maybe with its microscope, it could detect something that sort of looks like life. But beyond that, there really hasn't been much of an attempt to search for life. In fact, it's kind of forbidden. It's, for the longest time, saying that you were looking for life was the fastest way to not get any research funding for your proposal. It's only in the last couple of years that serious attempts, like the field of astrobiology, serious attempts to look for life on other worlds, is being considered a good thing, a worthwhile goal, the kind of thing that can get funding. So I would go like, we explore space to make life better on Earth. We explore space to understand the solar system, and then a bunch of other stuff, and then search for life. It's just, I think we all know that it's such an interesting subject that we want to talk about it more. And so we as the fans of space want to bring this topic up. Sid Parashar. Hey, Fraser, with James Webb, is it possible that the radius of the universe could increase in all directions? And what will James Webb's qualities be? No, James Webb will not be able to let us see any farther into the universe than any previous telescope. It will, in fact, like back in the 1960s, when they made the first map of the cosmic microwave background radiation, or they detected the cosmic microwave background radiation, that was the farthest observation that we will ever be able to make with telescopes. And this is a point that was where the light was released about 300,000 years after the Big Bang. And before that, the entire universe was like the inside of a star. It was opaque. You couldn't see through it. And so it's not like with a better telescope, you can just see farther into this sphere around the Earth. Literally, we already can see the farthest that we can see, and it is this wall of the beginning of the universe. We can see all of the bits in between with higher resolution, with better telescopes, but we'll never be able to see all the way beyond that because it's the beginning of time, and we can't see before the beginning of time. And so regarding your question about James Webb, I've actually done a bunch of interviews and stuff. We did an episode a couple of months back with one of the people who's choosing all the science goals for James Webb. So you might want to look into that. And I've done an interview with one of the engineers on James Webb and sort of talk about the state of the actual telescope. We talk a bit about that as well. So you might want to look into that. You can cut that last part out, Chad. That's for you, Sid. Larry Beckham, how could James Webb differentiate a Dyson swarm for something else? I don't know if it could. Like a Dyson swarm would look like a really weird infrared signature. It would be a large blob, but it's infrared. So it would be hard to explain a Dyson swarm, the infrared signature of a Dyson swarm, and it to be something natural. You just don't get those kinds of things. So I haven't looked into the Firefly small sat launcher. This is Scramble's question. I mean, I don't think there's much market left for small sat launchers at all once Starship flies. Like Starship is going to gobble up the small sat launch and the large satellite launch. Like Starship is going to go after it all. The only possible way to stop them is to come up with a fully reusable rocket technology that's able to compete with them. Like something that Relativity Space is doing. Is that the company, right? With the 3D rockets. They're planning on building a fully reusable two-stage rocket. I mean, even heard today, it looks like there's some problems with the BE-4, which is the engine produced by Blue Origin that's going to be being used by the Vulcan rocket. It looks like they're having problems getting it to work properly, and it might delay the initial test launches of the Vulcan. And the Vulcan isn't even fully reusable. Like, it just feels like SpaceX is running away with this whole thing, you know, and a Starship could take an entire Spaceship 2, put it inside, fly to space, release it, pick it up again, bring it back down to Earth. Everybody got their chance to be space tourists. Like, it's game changing. I thirst. All right. Oh, I already answered one of your questions, Celestial Navigator. Okay, I'll give this one quick. Celestial Navigator, do you think it's likely that extraterrestrial civilizations have detected us? If extraterrestrial civilizations exist, then it is 100% certain that they have detected us, that they know we're here. That really the moment that oxygen started releasing, or once life, cyanobacteria, started releasing oxygen into the atmosphere, once humanity came along, started producing pollution, we have been broadcasting our existence out to the universe. And so 500 million years ago, we got oxygen in our atmosphere. That's a sphere around the Earth 500 million light years away. That is, that's really far away. So yeah, if there's any aliens and they've built big telescopes, like the kinds of telescopes that we're imagining into the future, they could be watching us right now from halfway across the Milky Way, no problem, and know that we're here. Yeah, there's no place to hide. There's no way to hide our existence from. So when people always say like, oh, you know, we shouldn't be broadcasting to aliens, jig's up. They know we're here. If they're out there, they know we're here. And soon we'll know they're there. They are there. They're there. They're there. Kyle Hunt, what's the status on missions to Titan? No change in status. Just one mission, Dragonfly. That's it. 2035, I think you'll get there. I hope I'm still alive. Let's see. Rob Fowler, any thought of bringing back the star parties, even if less frequently than before? Probably not. The only way that I would do that is if I set up a telescope at my property in the near future. If I do that, then I've got access to a telescope that I can use in the horrible rainy West Coast weather. We've tried many iterations of the star parties, and it requires very expensive gear. It requires a lot of moving parts. It requires a lot of volunteers. There's no financial incentive for anybody, so it's not like I can pay people. I don't get paid, so it's it's pretty tricky to be able to do that. And we tried, and we still were able to kind of make it work. And so I really feel like until I can get my hands on telescopes directly, make that go, it's just not going to work. Like even we had the amazing assistance of Oceanside Photo and Telescope, but it wasn't their priority. They're trying to run a telescope company, telescope shop, and so to be able to make telescopes available for us to use is just really hard for them to be able to maintain it and justify it. So I just got too hard to be able to do. So I loved it. It was a really good time, and I know a lot of people really enjoyed it. And I think the way that will work is when I have a telescope in front of me, or that's right nearby me that I can operate, and then bring in other astronomy friends all at the same time and do it that way. I can't imagine a way that we could make it work. And we tried it before, and then we had to retire it, and then we tried to bring it back and worked a bit, but then we had to retire it. I think that's just the future of it, unfortunately. It's tough. Maybe if Universe Today becomes a bigger operation in the future and we have more funds, then that's a thing that we could sort of afford to maintain and actually pay for telescopes and pay for telescope time. But you're looking at thousands of dollars a month per telescope to keep them operational, plus people's time to operate them, if you want to provide like a good experience without having to just rely on the goodwill of volunteers. And as we saw, like the goodwill of volunteers only goes so far. And I don't have enough money for it. So, K. Maxon, have you interviewed Dr. Becky? I haven't interviewed her. She did a guest QA. So if you search for my channel for Dr. Becky, you'll find the guest QA that she did. I'll talk to her. We should totally do just a conversation. So I will, here, tell you what, I will write an email right now. Okay. I'll remind myself to write an email right now. Okay. I'll reach out to her. Promise. Hopefully we can get that done before the hiatus. Because she's great. Nathan Conklin, any thoughts on the similarity of strings in the standard model when compared to filaments in the cosmic web? Similarity of quantum probability distribution compared to cosmic background radiation? Sometimes things just look the same. Sometimes they just, like when you look at the universe at the largest scale, these amazing, one second here. I'm going to answer this one for real. Okay, hold on. All right. Nathan Conklin, any thoughts on the similarity of strings in the standard model when compared to filaments in the cosmic web? Similarity of quantum probability distribution compared to cosmic background radiation? All right. So sometimes things just look the same. It's like a coincidence. Another example of that is like the similarity of the large-scale structure of the universe to the neuron pathways of the brain. But when you have, like in the case of the universe, you've got gravity pulling things and concentrating things in a way that is very similar to if a brain is attempting, or a slime mold is attempting to grab as much space with the minimum amount of volume possible, then you get those similar shapes. And so, a lot of times we see these similarities in various parts of physics, and they're just a coincidence. So, I don't know if there's any deeper meaning in those coincidences. So, I don't know if I'm the right person to ask that question to. All right, we'll do like one more question, and then we'll go into overtime. All right. Nataspin 900, what do you think is the future of space propulsion systems? I think chemical rockets are going to be with us for a long time. They really they do the job, and as we move out into space and we think about possibly gathering our resources locally, there's nothing simpler than taking water ice, splitting it with electricity into hydrogen and oxygen, pressurizing them, and then you've got a liquid oxygen rocket system, like the space shuttle. So there are some other propulsion systems which are great, like ion engines, which allow you to have a sort of higher top speed in the end with a lower amount of mass used up. But they have very slow rates of acceleration. So they have their downsides, although the Chinese have put a ion system onto their space station, which is kind of cool. So I don't think that we're going to see any large developments in propulsion systems for a long time. There are other ideas that give you, obviously nuclear rockets can give you a higher specific impulse, but there are downsides to launching nuclear reactors to space. So I think the future of propulsion for a long time, like for decades, maybe 100 years, is going to be just different versions of chemical rockets. But sort of like the car engine, right? The gasoline engine has been used for a long time because it works really well. And you can imagine space being a similar situation. Okay. All right, let's go into overtime. So let me just do the outros, and then we'll go from there. More questions in a second, but first I'd like to thank our patrons: Charles Eubanks, Henrik Bo Anderson, Tomorrow, Walter Palmer, Eric Lunan, and the rest of our 834 patrons for their generous support. Want our videos early with no ads? Join our community at patreon.com/universetoday. I'll do the other outro. All right, well, those are the questions this week. Thank you, everybody who joined me live and also asked offline. Again, if you want to join the show live, come every Monday at 5 p.m. Pacific time and join the chat and ask your question and even follow-up questions. It's a lot of fun. All right, we'll see you next week. If you want a single comprehensive resource for space news, you'll want to subscribe to my weekly email newsletter. Every Friday, I send out a magazine of space news with dozens of stories, pictures, brief highlights about the story, and links so you can find out more. Go to universetoday.com/newsletter to sign up. It's totally free. And did you know that all of my videos are also available in a handy audio podcast format so that you can have the latest episodes as well as special bonus material like interviews with me show up on your audio device? Go to universetoday.com/audio or search for Universe Today on iTunes, Spotify, or wherever you get your podcasts. And I'll put a link in the show notes. Thanks, as always, to the moderators, and a special thanks to Chad Weber and Nancy Graziano. All right. I will stop the recordings. Boop, boop, boop. Okay. Right. Let's see. So what do I think about the Vasimir rocket? I mean, we've been talking about the Vasimir rocket now. It feels like forever. So I'm not sure what's taking so long. Maybe it's more complicated than anybody was expecting. Yeah, so Larry Beckham, the new Tiangong space station has ion thrusters. What is the reaction mass? I don't know what their reaction mass is. I would assume it's xenon, but the Starlinks use krypton, so maybe they're using krypton. Andrew Planet, does radiation build up pressure if it's contained? Yeah, the sun is radiation contained by gravity, and in fact it's the radiation pressure pushing outward that is holding the sun and stopping it from collapsing in on itself. So yeah, absolutely. Now it's been 900. Will Elon take alcohol to Mars? Absolutely. Well, somebody will, or they'll make it on Mars. Oh, there you go. Zaffan is saying, watch the Vasimir debate with Robert Zubrin. What, does he have a problem with the Vasimir? I mean, I guess because it's a debate. Bilal Hindustiki, can we ask the questions here? Is it just a set list? No, you ask the questions right here. But we already finished the show, so no one will see these answers except for you and these people. But yeah, normally on the Mondays, you just show up, ask any questions, bring the questions that you've been thinking about, and we'll grind through them as quickly as we can. BM Woolgas, Fraser, I can assume based on your belief that life only exists on Earth, that you also believe the universe is finite, since an infinite universe would have infinite life. No, I have no opinion on whether or not the universe is finite or infinite. When I say the observable universe is, the observable universe doesn't seem to have any other life. If the universe is infinite, then just through math, life has to be there an infinite number of times. It's just so rare that it's never happened again in the observable universe. Jolly Blonde Giant. Hey, Fraser, what do you think about all the cynicism in the comments in Science and Futurism channels? Do you think that maybe public officials might see this talk as a lack of public support? I'm going to need to know what you mean, because I don't see it in my comments. I find but maybe I've pushed away all of the people who are really negative and cynical, and all that remains are the people who are happy and positive. But I think we lead by example on the way. Like it would be super easy for me to run a channel where I just shit on other people, right? Like obviously, that's YouTube is driven by that, and I very purposefully have no interest in doing that. It doesn't. I don't like to watch it, and I don't like to do it, and so my growth as a channel is hindered because of it, obviously, but yeah. So I think, I have no opinion about that. Like I just do what I do. I am going to try to bring you an optimistic view, or an optimistic / realistic view of what I think is the future of space and exploration and astronomy that I'm excited and enthusiastic about what's happening so far and what's left to be discovered. I try to bring scientific rigor as much as I can, and try to ignore the negativity as best I can, or delete it before you see it. So, I think that, so Horizon Brave is saying that YouTube can be such a cesspool of negativity. It definitely can, but I also think that that's partly that's the tone that's set by the host, by the channel, that you as you run a channel, have a responsibility to foster the kind of community and the kind of audience that you want. And my hope is that there are certain people who watch me a couple of times and go, this isn't for me. I hate it. Like, why aren't you making fun of flat earthers? This is boring. And good, like, go. Like, it's not for you. But if people want to have a nuanced conversation about this kind of stuff, then this is your place. If you want to stick to the near future and try to avoid the far future, this is the place. So that's it. And I think that, and I want to create as inclusive and diverse the people that I talk to. So yeah. I kind of enjoy, I enjoy it not being the channel for a lot of people, and not having the same kind of following that some of the other people do doesn't bother me one bit. So, let's see. Hal McKinney, if you believe in a Big Bang, don't you believe in a finite universe? No. A Big Bang could have happened in an infinite universe, right? Didn't we talk about this? We imagine a Big Bang as this explosion of space, starting from a singularity, but it's just an expansion that the grid is getting bigger, and the grid could have been there right at the beginning of the universe, and it could have been infinite in all directions. And then things started just expanding from that point. Things got less dense over time. It was infinite then, before the Big Bang began, and it's infinite now. So you can absolutely have an infinite universe and a Big Bang. Like if I take a rubber band and I stretch the rubber band, then you might say, like, well, was there no rubber band before we started stretching the rubber band? I don't know if that analogy really works. Nancy Graziano, there may be a lot of negative streamers on YouTube. Best way to get your point across is not to watch them. They only continue because they're getting viewers. Yeah, I think, but it's real easy to be negative and to take pot shots at who you perceive to be your enemies. And it's much harder to have nuanced conversations with people who could very well be your enemies. I find that more fun. So, and a more interesting process. Nathan Conklin, your interview with Professor Lee Cronin is awesome. I'm still getting through it, but you're amazing at running an interview and challenging your guests. Good. I'm glad you like that. I feel like that's something that I'm getting much better at, for sure. And so, people are asking me, like, why don't you do the guide to space stuff? Like take me regurgitating Wikipedia and a couple of papers compared to me following my instincts and my knowledge with a subject matter expert like Lee Cronin today. Like, there's no compare. I could never go to the places that we went in that conversation with the level of depth with a person who knows that material that well. Like, it's an order of magnitude. And that's the thing that I'm grappling with as we sort of go back to this idea is that I've now gotten this taste of what's possible, of what kinds of ideas, how deep we can go, and tickling our brains with these ideas, and just this kind of high level regurgitation of facts from NASA's website just doesn't cut it for me anymore. So that is the issue. And the thing that's missing is the synthesis, where I'm taking one idea over here and one idea over here that are related, and I'm bringing them together. And so by just interviewing one person, that doesn't bring the synthesis. So that's the thing that I haven't figured out yet, but I will. Yeah. So that's what I'm trying to figure out. How do I have an interview depth of transfer of knowledge, but in a way that tells a narrative from multiple points of view, and is not just like, obviously, like if you watch like the History Channel, Science Channel, you've got some topic and you've got some person sitting in a chair and they're like, providing you some quotable quote. Like, that's not it. It's something else. I don't know what it is, and I'm just wrestling with it, and you're watching me wrestle with it, and I hope you're being entertained. So I think the only way out is through, and that is way more interviews, like an interview a day. Like, that's kind of where I'm wanting to go, which might be too much. What are some of the things on my bookshelf? I don't know if you could see. Parsec Awards for the Guide to Space, which I say isn't good enough. A meteorite my wife gave me. Up there's Mount St. Helens ash and a piece of pumice. Our book, Guide to the Cosmos. I don't know if you can see down there. That's my daughter, Chloe, when she was like 6 months old. Maybe a year. The YouTube thing, some space books. I don't know if you can see over there. Let's see. Yeah, so they're mini museums. These are cool. These are, again, a gift from my wife. I don't know if you've seen these. I don't know if it's all. I have to. It's going to try to focus through my. What if I'm not in the scene? So these are like little things. Like, this is a chunk of asteroid, Japanese star sand, a piece of a stegosaurus, piece of medieval chainmail. So they just take like things that we could never own, and they slice them up. They slice them up really small, and give them to us. Oh yeah, the Astronomy Cast 500 plaque is there. The memorial lecture that I gave for the Royal Astronomical Society. So there you go. Meteorite, aren't they insanely expensive? No, meteorites are cheap. Do a search on eBay for you want Campos del Cielo, which was a meteorite strike that hit Argentina about 5,000 years ago, and you can buy them like really cheap. Like I give them away. So you can't see this in scene, but so when I go like to conferences and stuff, I bring meteorites and I give them as gifts. So each one of these is about maybe like 30 grams or so. It's about feels like about half a pound of meteorites there, and you can buy them cheap. So, and then just, you can't see off site. I've got a couple of pieces of the James Webb sun shield. So these are the layers of the sun shield. You can see. I know it really wants to show you my eyes. So that's really cool. And those are given to us by the folks at James Webb. But yeah. So you have to be kind of careful. But no, you can buy like a really nice like fist-sized meteorite. Yeah. So Nancy's saying check out aerolite meteorites. Yeah, they're probably the best people to talk to. But you can buy like a fist-sized meteorite, something that weighs like a kilogram of solid metal that totally looks like a piece of space metal for hundreds of dollars. But you can buy small ones for $20, $30. So they're not that expensive to own a meteorite, and nothing makes you feel like you're holding a piece of exotic space metal than owning a meteorite. Yeah, I love them. So, and what they are is they were a bigger chunk of meteorite, but they crystallize inside the so imagine you get like a great big meteor. So what they'll often do is they'll have like a bigger one, and then they'll bash it, and it will shatter into all of the various crystals that make up the meteorite. And so that's what these little parts are. But you can buy bags of them. Yeah, it's pretty cool. So I highly recommend it. Yeah, metal from space. They may or may not give you a superpower. I can't confirm or deny. All right. Well, I think we've reached the end of this. Thank you, everybody, for hanging out this week. Super fun. Hopefully, we'll have last week's episode released soon, and we'll go from there. So, all right. Another episode of the Weekly Space Hangout on Wednesday. Another episode of Astronomy Cast on Friday. And I think that's the last one for the season on Friday. Nancy can confirm. Yeah. All right. Thanks, everyone.